Hello again, this is Andrea, and in this video we're going to be talking about subtracting integers and real numbers. So I'm going to say right up front here that subtraction of signed numbers tends to be one of the most tricky topics that students encounter in pre-algebra. For whatever reasons, our brain, it doesn't kind of wrap around the idea of subtracting negatives and subtracting positives and negatives, especially when you get a bunch of them together. So I'm going to ask that you be patient with yourselves, practice the heck out of these, find a method that works, and just practice that and stick with it. Okay, and eventually you will be able to do these, quicker, more efficiently, and it won't feel quite so stressful. For some of you, that may not be the case. You might have found something, years ago when you first learned this. And so whatever method you're using, if it works, please stick with it. Do not change and to any of my methods. If what you're doing already is working, that's great. All right, guys, so there's a couple of methods or kind of tools that I want to bring up to you that I think would be helpful. One of the first things I want to talk about is something I call side-by-side signs. And these little rules are for when two signs sit next to each other with no number in between. You can actually have a parenthesis in between the two numbers, that's fine, but you can't have a number in between. Okay, and if that's the case, if those two signs are sitting next to each other, we can replace it with a single sign or operation. Now, I know that on NROC, they actually teach to take a subtraction and turn it into adding a negative. So they're taking one sign and having you create two out of it. For some students, that's very helpful when you're learning this subtraction of signed numbers. So if that's helpful to you, please use it. And I am actually going to talk about that here in a minute and how you would do that. But I will let you know too that when you get into Unit 10 and we start to get into equations where we're solving for an unknown, we're solving for a variable, we're going to want one sign, not two signs. So if you do change the one sign to two in order to be able to do the subtraction, I'd like you to keep in mind that as you get this down to kind of move back in the other direction. Okay, it's kind of a tough quandary to be in, because it is helpful to learn the subtraction of signed numbers, but it actually can be difficult later. Okay, guys, so let's get back to this whole idea of side-by-side signs. The idea is if we have the same sign, we actually add, right? We use a plus sign or we add. So for some examples of that, here we have 2 minus a negative 5. When you have that situation, you see that the only thing that's between those two signs is the left side of that parenthesis. So that's what we consider side-by-side signs. We can change that to an addition sign. And now we just have 2 plus 5, right? So we know that's 7. Here we go again. 2 negatives, those are the same sign, right? So we can say that this is negative 8 plus 3. We're overdrawn $8, and we add 3, we are at negative 5. Okay, I want you to be careful of a couple things though. You notice so far when we were doing that, when we were using the side-by-side signs, we only had one number in here. You notice we had the negative 5, and here we had the negative 3. You notice in this example over here, we have some other things going on. We've got two terms inside that parenthesis. So this actually, in this situation, we have to do this math first before we could grab. For example, what I'm saying is we can't do this. Okay, we cannot do that. If we do that, what we're doing is we're basically not following the order of operations. That's kind of what we're getting down to here. So we would say negative 8 plus 2, negative 6. Okay, and then we would write everything down exactly like it was, and we would just start over. Now we can go back and we can grab the two signs that are sitting side by side and change those to an addition. So now we have 3 minus 7 plus 6. Well, if I have $3 and I spend 7, once again, I'm not being very good with my money. Negative 4 plus 6. But I do actually have enough to deposit to bring my account to a positive 2. All right. The other thing I want to show you that I want you to be careful of is that this is not a situation of a side-by-side sign. Do you see in this situation, we've got that 4 in the middle. So that is not a side-by-side. We cannot grab both of those negatives and make it a positive, right? We would actually have to just work on the fact that this is, and we're going to get into, a couple of options on how we would solve this, or how we would simplify this expression here. But negative 4 minus 6, there's lots of ways to look at that. If we were on a number line, we would go down to negative 4 and then keep going down an additional 6, right? Which would bring us to negative 10. If we were thinking of money, we are overdrawn 4 and we spend 6 more. So we're at negative 10. All right, let's practice some of these same methods that we talked about when we were talking about addition in the other video. Number line is also good for subtraction. And of course, we would just start at that negative 2. So I'm just going to put a little dot here. So we're starting there at our negative 2. Okay, and then we're just using each number separately, keeping in mind that down here is our negatives, up here are our positives. So we would go down 4, negative 4, 1, 2, 3, 4, and we would be here at negative 6, right? And now we have a side-by-side sign, don't we? 2 negatives make a positive. So what we would do, it really clears up quickly that we have this double negative. Well, we know a double negative, when we're speaking, we don't even talk in double negatives. That's actually not correct grammar. So a double negative is a positive. So this actually ended up being negative 2 minus 4 plus 9. Okay, so now we know which direction to go. Well, we could jump all the way back here, which would be a plus 4, 5, 6, 7, 8, and 9. Okay, so this was the plus 9. So if we were using a number line, we would get to that answer of 3. All right, so for those of you who liked the rule for addition, you can actually use that rule. I know I did caution about that just a minute ago, but they do talk about this idea of additive inverse that helps us to change a subtraction to an addition. Once we do that, we can use the rules for addition that you learned in the other video where we have same signs. If we have same signs, we follow a couple of steps, and we have different signs, we follow a couple of steps. Let's talk about this idea of additive inverse. There are curriculums that call this a 2 pencil stroke method. So instead of having a minus 4, what we are doing is adding a negative, right? So we could say that this is negative 21 plus a negative 14. So what we did is we created 2 signs out of just that original subtraction. And we do that just to be able to think through the subtraction easier. We follow the signs of, follow the rule. Okay, we have the same sign. So we take the absolute value of those numbers. Remember, when we're taking the absolute value of the numbers, we're actually just ignoring the sign on them. So we're basically saying 21 plus 14. That's going to give me 35. And then we use the common sign. And we can see that both of these had a subtraction, or you can look below, they both have a subtraction. So you would have applied that subtraction sign. Okay, let's look at this example here. These signs are different. This is a +4 and that's a negative 18. Of course, we could have rewritten this using that additive inverse idea if we want to. And now we have opposite signs, right? Different signs. We have a plus sign here, a minus sign there. Well, when we have different signs, we find the difference of the absolute value of the numbers, right? We always start with the larger number, so we say 18 minus 4 gives us 14. And we always use the sign of the larger number, which is 18, so we would call that a negative 14. So that's another option for you if you prefer to use that rule for your subtraction. I still like the idea of money. I always tend to go more toward thinking through a problem either visually or kind of reasoning it out with some number sense rather than going through a step-by-step rule. But that's me, and it may not be you. So you find what works for you. Money, of course, we know we can all totally relate to that. And when we have subtraction, sometimes we have these double signs. With addition, we had double signs too, but adding a positive, we already know is addition. Two positives, right? It's just a positive. That was more of a common sense thing, so I didn't add that. But here, if we have negative signs, of course we know that means spend. And if we have a double negative, right? A double negative, that was this idea of the side-by-side negatives. We know that we changed that to a positive, right? So that ended up being addition or a deposit. So a double negative means a positive or a deposit in terms of money. Of course, we already know that a positive means deposit. All right, so let's look at this example that includes addition and subtraction. Okay, we start out at being overdrawn by $2, and of course here this means spend. We're spending 7 more, right? So we're really overdrawn right now, aren't we? Okay, we're overdrawn by $9. Now, I notice a side-by-side sign here, and I only have one number in my parentheses, so I can go ahead and change that to a positive 9, right? Now, from here, you guys have some options. I'm going to go ahead and bring this down as is. But if you had wanted to, I'm going to just write it again over here, and we already knew the negative 9 plus 9. But you could have grabbed these side-by-side signs and just made it a subtraction. We know that different signs means subtraction, right? Same side-by-side signs mean addition. Different side-by-side signs mean subtraction. So if you tend to like just one operation in there, that's what you would do. If you tend to like this, you know, adding a negative like what we have here, then you would keep it that way. Well, we know that negative 9 plus 9 is 0. So over here and over here, we can see we have a negative 3 plus 4. So however you want to finish that problem, overdrawn by $3 and you deposit 4, we know we would have $1 left. All right. Now, of course, we are going to have some variables thrown into our subtraction problems as well, right? So we need to remember about combining like terms. We have talked about combining like terms in the last couple of videos. We know that like terms have exactly the same variable part and exactly the same exponent part. When we're combining like terms, we have 2 steps. We add or subtract the coefficients or the number part, but we keep that variable part the same, right? So in this case, we're going to take that 3 and we're subtracting 4. 3 minus 4 is negative 1x, or what we would do is just write it as negative x. if you guys wrote it down as negative 1x, I would never count that as wrong because it's correct as well. It's just that we usually drop that 1. We don't necessarily need it. Okay, let's look at this second example. 13xy minus a negative. Well, here we have a side by side, right? So we actually have 13 plus 9 of these xy's, which gives us a 22xy. And over here we've got some stuff going on, so we want to make sure that we are finding our like terms. We have x squared y's, and here we have x squared y's. We grab the sign in front of that coefficient. Okay, so here we have a negative 1. So we have negative 1 minus 3 of these x squared y's. Well, negative 1 minus 3. I'm down 1. I spend 3 more. I am at negative 4 on my x squared y's. And we can see that here. And this little guy is just sitting by itself. There's no like term with him. So he just kind of gets sat at the back there. As a reminder, we don't use, we don't combine like terms with multiplication and division. We use the exponent rules. We talked about this in the last video. We would multiply the number parts, so there's where we get that 12, and then we use product rule, which means we add those exponents. We have a 12x squared, and once again our x squareds go out because x squared divided by x squared is 1, and 14 divided by 7 just gives us a 2. All right, let's do some operations here with some of these problems that have subtraction and that also contain variables. So here in our first example, we have some fractions. They also contain variables. So if we look close enough, though, we can see that they both just have x's. So these are like terms. Okay, so one method, I mean, you don't have to do it this way, but one method you can do just so it may feel a little bit cleaner, you can leave that x out off to the side, kind of what we were doing before. We were doing the math, so to speak, with the coefficients first, and then we were just attaching that variable at the end. We could say that then this is just negative 1/2 minus a negative. Well, I don't like that. That's too much going on. Side by side signs. 2 negatives make a positive, so I'm going to add 1/4. And I'm just dragging that x along because I know I'm going to attach that in the end. And now all I really need to do is think about my fraction rules here. I've got an addition of fractions. So I need common denominators. Common denominator there is 4. Okay, well, this is going to give me a negative 2 plus 1. Be careful of that negative sitting right here. We're going to attach that always. When we're doing calculations and we have to add something in the numerator, attach it up to the numerator so that you can include it in the math, right? It doesn't ever go down to the denominator, by the way. Negative 2 plus 1 is negative 1. And you can leave it like this, or more often, if you have a fraction in its final form that has a negative in it, you will just drag that negative out front and you will call it the negative, just negative 1/4 x. Okay? All right, guys, here we go. Let's try the second one. All right, let's find out if these are all like terms. Well, I've got negative 3y's here, 8y's, and negative 6y's. So those are all y's, so I'm good there. I also noticed that I have side-by-side signs, and I only have one number in that parenthesis, so I can grab that other negative there, and we'll call that double negative a positive. So here I've got negative 3y plus 8y plus 6y. And you can just mentally do this. You can say negative 3 plus 8 plus 6. Or if you really like to kind of show what you're doing, you can write it out. I showed that as a method, but it's definitely not something you have to do. Excuse me. Negative 3 plus 8 is going to give me 5, and 5 plus 6 is going to give me 11 y's. So you guys could have literally taken it from here and just written the answer. Okay, if you want to just add and subtract those coefficients mentally, totally fine. All right, so this last example here, we can see that we're dealing with all x's. So those are all like terms, so we're happy about that. We can also see that this is going to be a plus 3x. And there's a lot going on here. There's a lot of coefficients. So in this particular case, I am also going to just take these coefficients and do some work with them out front here. All right, so we've got negative 22 plus 5. It's going to give me negative 17 minus 10 plus 3 plus 15. You guys can do some mental math here too. You know, you don't always have to write every single teeny little thing down. I want to give you guys the freedom to do that, especially if you just are careful about grabbing signs together. You guys could call this negative 27. Of course, this is going to be plus 18, right? You guys can totally do that. Easy peasy. Okay. Negative 27 plus 18 is going to give me a negative 9. I might have made a mistake there. Hang on. 8. Oh, no, I made a mistake when I was working on it earlier because I had called this an 8 instead of a 3x. So we're good. Okay, so we are going to, so negative 27 plus 3 is going to give us a negative 19. 9, negative 9. Sorry, guys. Losing my mind. Negative 9x. Okay, there we go. All right. Now, lastly, but not least important, I want to talk to you a little bit about application problems using subtraction. We will be doing application problems, of course, in all of our units from here on out, and we're building up to eventually using a 5 or 6 step problem solving process. So right now, though, we're just kind of taking that piece by piece, and we're kind of just starting to think about what is involved in answering these word problems. One of the things that's going to be really important for you guys to do is to list your knowns, which we call the given information. We just consider that given information, and the unknown. And that's really just saying, what are we looking for? You know, what is it asking us to answer? So we want to make sure we know that. Now you can list it off to the side. You can also just highlight it, right? You can kind of do it how you need to. Now, later on in the quarter, you're going to actually have to list it out to the side. This is my unknown, and I'm going to call this X, something like that. For now, we just want to make sure that we're aware of the knowns and unknowns. It's super duper important here to write an expression, okay, using the knowns. And you're writing an expression to represent the problem. Here's where you want to show your steps, because here's where your points come from me. Then you're going to be asked to simplify the expression, of course, so that you can answer the question. And we're really asking you guys to not use your calculator, okay? Please don't use your calculator. I mean, if you have tedious decimal problems, and there will be some, that you really want to, or you want to check your work, of course you can do that. But, you know, in terms of fractions and kind of this initial, pre-algebra kind of foundational concepts, we really want you guys to get some number sense, which means you don't use your calculator and you really think through things yourself. All right, example 1. On a cold day in Minneapolis, the temperature stood 12 degrees below zero at 2 p.m. Over the next 5 hours, the temperature rose 6 degrees, dropped 2 degrees, rose 5 degrees, dropped 1 degree, and finally dropped 3 degrees. What was the temperature at 7 p.m.? All right, so you could, if you wanted to, you know, list all your knowns over here, right? I think in this particular situation, since you have so many of them, I would probably go through and just highlight them. What we did is we started at 12 degrees below zero, right? Over the next 5 hours, the temperature rose 6 degrees, dropped 2, rose 5, dropped 1, dropped 3. Okay, I think what I would do in terms of that known information is making sure that you have the correct integer for these. So when we're talking about 12 degrees below zero, we're talking about a negative 12, aren't we? If it rose 6, we're talking about plus 6, minus 2, plus 5, minus 1, minus 3. All right. So we have the known information, the known integers that we're going to be using. The unknown, in the end, what we're really wanting to know is the temperature in degrees. Temperature in degrees at 7 p.m. Okay, so this is what we're going to be looking for. All right, so we want to just list our expression out. Remember, this is where a lot of your points come from. Okay, so we start at 12 degrees below zero, minus 12, plus 6, minus 2, plus 5, minus 1, minus 3. Okay, and how we answer that question is just going through and doing the math, right? All right. So here we go. Whatever method you want to use, if you want to use the rules, if you want to think about this in terms of the number line, thinking about money, however you want to do this is great. I'm just going to kind of stick with the money idea. Some students, actually, I will point out, some students like to go through and collect all the negatives and collect all the positives and then put them together. That would be totally fine. Just be very, very careful that you grab the sign that is right in front of the number. I'm going to just step it across because I think that's the safest. Negative 12 plus 6. So I'm overdrawn 12 and I deposit 6. I'm going to be at minus 6 degrees. And I'm just writing everything else down, even though kind of is a pain in the bum. All right, negative 6 minus 2, negative 8. Plus 5. And I might just take a little shortcut here. I know that negative 1 minus 3 is negative 4. I might just cut that off of the end there. Negative 8 plus 5. Negative 3 minus 4. Okay, I'm overdrawn still, so negative 7. I want to go back to my question. What is the temperature in degrees, right? Because we always have a unit. We need to make sure we always include our unit here, and we know that's degrees. And we would like to write out our solution, our answer. That's usually what we do with an application problem. So we can just write that out. So at 7 p.m., the temperature was a minus 7 degrees. Didn't they list Fahrenheit or Celsius? They didn't, so I guess we could just leave it like that. Or you could say 7 degrees below zero, whatever you want to do. Okay, guys, and lastly, let's take a look at example number 2. We're going to do exactly the same thing. So let's go through and do some highlighting of some given information. The height of Mount Rainier is 14,410 feet. The lowest point in Death Valley is a negative 288 feet. What is the difference in the altitude between these 2 points? Okay, I would highlight some important information. That word difference is super important. The word difference actually means subtraction, right? And we're wanting to know, this is our unknown, what is the difference in altitude between those 2 points? Okay. Known information, obviously we have those positive and negative signs already, so we have that information here in terms of our knowns. And unknown, What I'm looking for is the difference in altitudes in the two altitudes, I guess I could say. So this is my unknown. Okay, guys, so we want to write that expression out. So if we're trying to find the difference, of course, we take the highest point, 410, and the word difference means subtraction, and the lowest point is already a negative. So this can be a teeny bit confusing. But if we were, let's say we could, basically crawl through the very center of the earth. We could crawl through that Mount Rainier at the top and crawl right straight down to ground level and keep going down and get to the lowest point in Death Valley at one straight line. We know that we're adding the height of Mount Rainier and the height of Death Valley to each other, right? Because we're traveling that whole distance. So that's where this idea of the difference of a negative here, this subtracting a negative, and that's why we add here. So 14,410 plus 288. Okay, well that's going to give us 14,698. And we are looking for our unit, so of course we know that that's in feet. Okay, and we would answer the question. We make sure we answer that question, that the difference in altitudes is 14,698 feet. All right, guys. So that's a couple of examples of your application problems. And of course, you have quite a few more that you can work on as well. So just practice, practice, practice. As you know, that makes perfect. Okay, guys. We'll talk to you soon.